Section 5.5 Example 5 says the rowing club is renting a 57-passenger bus for a day trip. The cost of the bus is $750. 5 passengers will be chaperones. If the students who attend share the bus cost equally, what function models the cost per student C with respect to the number of students N who attend? What is the domain of the function? How many students must ride the bus to make the cost per student no more than $20? It's important to point out what we know, what we need, and make a plan. So the things we know are that the bus holds 57 passengers, the cost is going to be $750, and there are 5 chaperones who will not be paying for the bus. What we need is a function for the cost per student. That was this piece right here. We also need to point out the domain and then figure out how many students must ride the bus to make the cost no more than $20. A plan is to write the reciprocal function for the situation and then graph the function and solve an inequality using the $20 limit. The first thing we want to make is a function that represents the situation. So we know we're looking for the cost, and the cost is $750, but that is divided up among every student who is on the bus. So that would be divided by N, since N is the number of students and C is the cost per student. Next, we want to look at the domain. Remember, the bus can only hold 57 passengers, but 5 of those are not going to be students, they will be chaperones. So if we consider 57 minus 5, that gives us a maximum of 52 students. Now, that's not the domain. You can't just say 52. We have to state what possible values we could have. Now, we know we can have 52 or less students on the bus. However, that also is not specific enough. We can't say less than or equal to 52 because that includes some negative numbers as well as 0. It wouldn't make sense to rent a bus if we weren't having any passengers that were students. They wouldn't get a bus if they had no students going. So you would need at least 1 student, and you have a maximum of 52. Next, we want to figure out how many students we need on the bus for the cost to be no more than $20. So remember, the cost is going to be represented by 750 over N, and we want to max out at $20. So we're saying it can equal $20, but we want to spend that or less per student. So we have the inequality 750 divided by N is less than or equal to 20. Now, we can do this using a graphing calculator. So you are going to graph 2 separate pieces. We're going to graph y1 will be the 750 over N. y2 will just be 20. And then once you find the point of intersection of those 2 pieces, that will tell us how many students we need to max out at $20 per student. So here's an example of what that graph will look like. This curve right here is going to be the 750 over N. We're only looking at the first quadrant because we're talking about students on a bus and cost. Now this straight line right here is going to be the y equals 20. So this intersection point right here is when x equals 37.5. However, the number of people must be a whole number. If we choose 37, the cost will be more than $20, so we have to round up. So for all values greater than or equal to 38, the cost is less than $20. All of this work is written out on the next slide. And now I would like you to try to solve the weight P in pounds that a beam can safely carry is inversely proportional to the distance D in feet between the supports of the beam. For a certain type of wooden beam, P equals 9,200 over D. What distance between the supports is needed to carry 1,200 pounds? Again, you can use Desmos or a graphing calculator once you have everything set up and you want to look at the intersection point.